This is the video for the 8.1a activity, Go the Distance. This is Unit 8, and in Unit 8, it is all about combining geometry and algebra, so connecting those two. We're introduced to the Crawford High School drill team. That's the group that this activity is based on. And it says, the performances of the Crawford High School drill team are very popular during halftime at the school's football and basketball games when the Crawford High School drill team choreographs the dance moves that they will do on the football field. They lay out their position on grid like the one shown. Okay, so right here, this is typically what they do, where each dot represents a dancer on the drill team. In one of their dances, they plan to make patterns holding long, wide ribbons that will span from one dancer in the middle to 6 other dancers. On the grid, their patterns look like this. Now, it's really helpful to recognize right off the bat if there are any ribbons between dancers that are the same length. So I'm going to go ahead and mark up anything that I think is the same length right here. So to me, it looks like these kind of diagonals are all the same length. And then these horizontal ones also look like they're the same length. Okay. For the question the dancers have is how long to make the ribbons. Do you see Gabriella right here at the center? So this is Gabriella right here. She's standing at the center, and some dancers think that the ribbon from Gabriella to Courtney will be shorter than the one from Gabriella to Brittany. So what we need to do is help them figure out how long each ribbon needs to be and explain how we found the length of each ribbon. Okay. So the easy ones to find are the horizontal ones. So from Gabriella to Courtney, it looks like it's the same length as from Gabriella to Felicity. And we can literally just count that. So that's going to be, let me zoom in right here. That's going to be 1, 2, 3, 4, 5 boxes. And let me just say that's like 5 feet. Okay. So that is 5 feet. Okay, now let's find those diagonals. It looks like from Gabriella to Brittany, it's going to be the same length as from Gabriella to whoever's at A. I don't think they named that dancer. And then Gabriella to whoever's at E. And then Gabriella to whoever's at D. So it looks like those will all be the same. The problem with finding this length from Gabriella to Brittany and the others is that it is a diagonal, right? This is a slanted line, so it's not so easy just to count boxes like we did from Gabriella to Courtney. If we did count boxes, it would be like these diagonals, and the distance of a diagonal is not the same as a horizontal distance. It's a little bit longer. So we need something else that can help us figure out this diagonal distance. I don't know if you remember from last year in 8th grade, but I'm going to remind you. There is a formula that we can use that can help us right here. If we draw a right triangle above or below our slanted line, we can actually use the Pythagorean theorem to figure out the length of the slanted line. So I'm actually going to redraw this down here. So we've got this right triangle going on, right? We don't know the slanted length here. Typically the slanted length is called the hypotenuse, so I call it C. Here's our right angle, and it looks like one of the sides is 4 boxes. So like 4 feet, and the other is also 4. Now for our Pythagorean theorem, the legs, which are the sides next to the 90-degree angle, are called A and B. So I'm going to just name this one A, and this one B. And then that helps us know what to plug into Pythagorean's theorem. So Pythagorean's theorem says that a squared plus b squared equals c squared. So I can replace a with 4. So I'll have 4 squared, and then b with also 4 squared, and that'll be c squared. 4 squared is 16. Another 4 squared is 16. So c squared adds up to 32. Now, it's kind of weird to think that the ribbon from Gabriella Courtney was 5 feet, and the ribbon from Gabriella Brittany is 32 feet. That just does not seem correct. This is actually a really common mistake using Pythagorean's theorem. Right here, we are solving for c, not c squared. Do you see this square right here? So we need to be really careful using Pythagorean's theorem, and always right at the end, we have to solve for c, not c squared, by taking the square root of both sides. So that gets rid of the square, and we end up with c is, I believe it's 5.7. And I'm just going to round to the 10th, so one space after the decimal, 5.7 feet. All right, so let's explain a little bit how we found the length of each ribbon. So from Gabriella to Courtney, and then also Gabriella to F, all we did was count the horizontal boxes. So count horizontal boxes. So that was pretty easy. But then when we found from Gabriella to Brittany and the other 3 ribbons, because they were a slanted length, we needed to use Pythagorean's theorem. Used Pythagorean theorem. And just a reminder, this only works on a right triangle, and that's why I had to draw a right triangle in around the line between Gabriella and Brittany in order to use this formula. All right, let's go ahead and move on to number 3. When they have finished with the ribbons in this position, they're considering using them to form a new pattern like this. Now the question is, will the ribbons they used in the previous pattern be long enough to go between Brittany and Courtney? So we don't know if we can reuse that the 2 5-foot ribbons or the 4 5.7-foot ribbons for this new pattern. So let's see if we can. And we need to explain your answer as we go. Okay, so it looks like that's a slanted line. So we need to draw a right triangle if we want to find that slanted length. So I'm going to just draw it in like that. And then I need to figure out the length of my legs. To find this horizontal leg right here, I can just subtract the 5 and the 3. So that is 2 feet long. And then to find my vertical leg right here, I'm going all the way from y is 0 up to y is 4. So that'll be 4. Okay. So now I need to plug into Pythagorean's theorem. 4 squared plus 2 squared equals c squared. That's going to be 16 plus 4 equals c squared. That'll be 20. And then I need to always be careful at the end and remember always to take the square root. So then I'll do square root, and so c, if I round to the 10th, will be 4.5 feet. Okay, so it looks as if between Brittany and Courtney, they'll need a ribbon that is shorter than all the ribbons they had previously. So seeing that, I'm going to say yes, they can reuse the ribbons. All right, Gabriella notices that the calculations she's making for the length of the ribbons remind her of math class. She says to the group, hey, I wonder if there's a process that we can use, like what we've been doing, to find the distance between any 2 points on the grid. She decides to think about it like this. I'm going to start with 2 points and draw the line between them that represents the distance I'm looking for. So she's trying to find that distance right there. Since the 2 points could be anywhere, I've named them A, which is just generic x1, y1, and B, which is just generic x2, y2. When I figured the length of the ribbons, what did I do next? So it asks us to think back on the process that we just used to find the length of the ribbon and write down our steps here. So it looks like our very first step is to draw a right triangle. That's what we did on the previous 2 examples. And it doesn't matter if I draw it above or below. I'm just going to draw it here below. There's our right triangle. Once we have our right triangle, we need to find the length of our 2 legs. So I'm going to call our first leg A. So I'm going to say find A. So I'm going to say this is A right here. And then our third step will be to find B. I'm actually going to change this so it's not just A, but it's leg A. And then find leg B. And then right at the end, we just used Pythagorean theorem to solve for C. So this will be C here. This will be B. Okay, so plug into Pythagorean theorem. Plug A and B. And I'm just going to abbreviate. I'm just going to write capital P, capital T with points, just so that I don't have to write out Pythagorean's theorem. So now the question is, if I don't know or cannot easily count the legs, is there another way to find leg A and B? So there is, using the ordered pairs. So if I want to find leg A, so this horizontal one right here, really what I'm doing is subtracting my x values because it's the horizontal leg. So I would go x2 minus x1. That is my horizontal leg. That's A. x2 minus x1. And then if I wanted to find my second leg, B, that's my vertical leg. All I would do is subtract my y's, right? These y's are the vertical leg. That would be y2 minus y1. So I'd say y2 minus y1. That means when I plug A and B into Pythagorean's theorem, if I use the notation that for just 2 generic points, I'm plugging it in like this. I'm really plugging in for A, x2 minus x1, and whatever that difference is, I'm squaring it. And then I'm adding that to parentheses y2 minus y1, squaring that to get my c squared. Where this right here is really just A, and this right here is really just B. Just that subtraction. So let's see if we can actually do this. So let's use the process that we just came up with to locate the distance between 2 points that are really far apart, so it doesn't make sense to graph and count. So we've got these 2 points that we're going to find the distance between. Okay, so the first distance we're going to find is leg A. So leg A. So in order to find that, we're going to subtract our x values. So here's our x1, here's our x2. So I'm going to say 23 minus negative and 11. And be careful when you subtract these that you're paying attention to double negatives, because right here, this double negative will become a plus sign. So this actually adds up to, I think it's 44. No, not 44, 34. Okay, so that's our first leg. And then we'll find leg B. So that's going to be the subtractant of our y's. So here I have y1, here I have y2. So I'm going to say negative 16 minus 25. So that's going to be negative 41. Okay, and don't be concerned if you get a negative length for a leg. When you square that negative leg, the negative goes away. So you'll see that in a minute. Okay, there we go. So let's go ahead and plug these into Pythagorean's theorem. So we're going to do 34 squared plus, and I'm going to be careful about the negative. So I'm going to go parentheses, negative 41 squared, because I want that negative to go away, right? A negative times negative will give me a positive here. So I need to square not just the 41, but the negative 41. That equals c squared. 34 squared is 1156. And then negative 41 squared is 1618. You see that negative went away. Didn't have to worry about it. That adds up to 2837 as c squared. So then we'll take the square root of both sides. And that gets us c is 53.3 feet. Okay. Which, if this was a ribbon for the drill team, that would be a very long ribbon. All right. And then it says, use your process to find the perimeter of the hexagon pattern shown in number 3. So this is where point A was, right here at negative 3, 4. So that's point A, and then point B, point C, point D, and E, and F. Okay, so they want us to find the perimeter, so we need to just remind ourselves what it means to find a perimeter. To find a perimeter, you add all the lines along the outside. 2 of these we can count, right? Because this one is the same as this one. So that just measures 6 long here and then 6 long here. So we're going to just say 6 plus 6. That's going to be our 2 horizontal ones. So that's 12. And then it looks as if all these slanted ones are the same. So I can put like double tick marks all the way around here. And we've actually already calculated that length. Remember from Brittany to Courtney, we calculated 4.5. Okay, and since all of these also have a triangle that we could draw around it of a leg of 4 and a leg of 2, they're also going to be 4.5. So we don't need to recalculate them. So that's going to be 4 times 4.5. So that's going to be, I think, 18. So it looks like we've got the 18 and the 12. So it looks like our perimeter is going to be 30 feet. Our last thing to do is our takeaways. For our takeaways, what we're going to do is we're going to fill in the steps in words and then in symbols that we can use in order to solve these problems. So the first thing always that we need to do is, if we're trying to find a slanted length, is draw a right triangle. Okay, so that's really important. Draw a right triangle. And then once we draw our right triangle, then we find our two legs. So find leg A, which I'm going to say is our horizontal leg. Horizontal. So that's going to be x2 minus x1. And then find leg B, and that's going to be the vertical leg. And that's going to be y2 minus y1. Once we've done that, then we plug those values into Pythagorean's theorem. Plug into, and I'm just going to write PT to shorthand Pythagorean's theorem. When we do that, Pythagorean's theorem, which normally looks like this, a squared plus b squared equals c squared, will look just a little bit different since we're, instead of a, we're doing the subtraction of x2 minus x1, and instead of b, we're doing the subtraction of y2 minus y1. So it's going to look like this. X2 minus x1 squared plus y2 minus y1, and that whole thing squared. So that equals c squared. Okay. When we solve this for c, we will end up taking the square root of both sides. So solve, zoom in a little bit, solve for c, and then it says take the square root. Okay, so we have to remember to do that. So when we do that, it's gonna, with this notation, it's gonna look like this. I'm just rewriting the two subtractions, and then we're going to take the square root of that whole thing and then take the square root of c squared. So what you end up with is c is the square root of my first leg A, which was x2 minus x1, the whole thing squared, plus my second leg B, y2 minus y1, that whole thing squared. And then that sum gets square root. Okay, this we actually call the distance formula, which is pretty much Pythagorean's theorem. It just has notation in it for ordered pairs as opposed to just writing A and B. Because remember, this part right here is just A, and this part right here is really just B. So we're just going to copy down the distance formula right here. So in case you see it somewhere online or next year, you'll know, oh, that's just Pythagorean's theorem. So the distance formula says the distance between 2 points, or the length of the hypotenuse C. So the distance formula uses D, but that's the same as C, is the square root of x2 minus x1 squared plus parentheses y2 minus y1 squared. Okay, again, same thing as Pythagorean's theorem. And just one reminder about finding the perimeter of a geometric shape on the coordinate plane. You're just adding the lengths of all the sides. That's all you're doing. Add the lengths of all the sides. And if any of the sides are slanted, make sure you use Pythagorean's theorem to find them. So I'm going to say slanted sides. Use Pythagorean's theorem, also known as the distance formula. Okay. In this lesson, we learned to find the distance between 2 points. We used the Pythagorean theorem to develop a formula that can be used whenever we need to find the length of a segment between 2 points. The formula can be applied to find the length of the sides of any geometric figure in the coordinate plane to calculate the perimeter. I hope this was a helpful video, and I wish you good luck on your practice.